Alright, so turn to a clean set of pages in your notebook. You should be on page 35 of your book. Review and reflect. For the review, there's two questions that say factor out the GCF. So you have 24x squared y squared minus 18xy. Number 2 is 18x to the third y squared plus 42x squared y cubed. And then the second two questions factor by grouping. 8r to the third minus 64r squared plus r minus 8. That's 4 terms, serial group. And number 4, 105n to the third plus 175n squared minus 75n minus 125. The reflection question says, list and describe the 4 steps of factoring trinomials and try to do so from memory. So try to remember the 4 steps that you're going to learn in this video for your reflection question. Alright, so pause the video, try all 4 review questions on your own, then play the video to hear the explanation. Alright, so on number 1 we have 24 and 18. Their GCF would be 6. X squared and x has a GCF of x. And then y squared and y has a GCF of y. That leaves you with 4xy minus 3. And if you multiply that back in, you should get back to your original expression. Here, between 18 and 42, they have a 6 in common. X cubed and x squared has an x squared in common. Y squared and y cubed has a y squared in common. That leaves 3x plus 7y. And again, if you multiply it back in, you'll get back to the original. So that is called factoring out the GCF. The second two is factor by grouping. So we're going to look at the first 2 terms. Take out what's common, 8r squared, and what remains, r minus 8. Then we'll look at the second 2 terms. They don't have anything in common, so we'll put a 1. The sign in front stays. And that also gives us r minus 8. If you did this right, your leftovers should match, and your answer would be 8r squared plus 1. And r minus 8. Same idea on number 4. These numbers are a little bit bigger. 105n to the third plus 175n squared. Now I don't know what those 2 numbers have in common. I'm going to start guessing. I assume they both divide by 5. And I'm going to go a little bit bigger. Let's see. Looks like they both divide by 35. And you can let your calculator kind of help you out with that guessing. What I did to get that number is I noticed that you get 21 and 35 when you divide by 5. And those can both divide by 7. So in my head I did the 5 times the 7 to get 35. Otherwise you just keep guessing. There is a function in the calculator. I did not show you guys this in class. If you go to Math, and then you go over to the number tab, so Math and then the number tab, and you go down with your down arrow, down, down, down. There's a button that says GCD, and that is kind of like GCF. I'm not sure what the D stands for, but if you hit enter and you type in your 2 numbers like 105, and the comma button which is above the 7, and then your other number like 135. So if your numbers are big, like over 100, and you're not sure what the GCF is, you go to Math, over to Number, choose GCD, type in the 2 numbers with a comma, and hit enter. Oh, did it say 15? Oh, it's 175, my bad. Math, Number, GCD, 105, comma, 175. And it will tell you what the GCF is. So that's there for the bigger numbers. I wouldn't use that all the time, but if the numbers are kind of big, that can help. So it should be 35 n squared And 105 divided by 35 is 3n plus, divide that out, 5. The second two terms minus, between 75 and 125, they should have 25 in common. And that should leave you the same expression, 3n plus 5. Sorry, I ran myself out of room. But that minus becomes a plus when you take out that first minus. So your answer should be 35n squared minus 25, and then 3n plus 5. And if you multiply those back together, you'll get back to your original expression. Alright, so just practicing GCF and grouping. We're going to need both of these skills for what we're going to learn in this video. So make sure you practice that before you try what we're about to do. And now we're going to be on page 36. This is section 6.2 in your textbook, factoring trinomials when a equals 1. And you don't know what that means yet, but you'll learn here in this video. And I'm going to work on plain paper for this so you can follow along a little bit better. Alright. Pause this video anytime you need to. Go back, watch it again, pause it so you can write something down, pause it to try different problems on your own, whatever you need to do. This is again page 36 in your notebook. Alright. So trinomials, which remember means three-term polynomials, trinomials, are generally written in the form ax squared plus bx plus c. So ax squared plus bx plus c, where a, b, and c are integers. So you'll have a number in front of x squared, a coefficient, a number in front of x, a different coefficient, and then a number by itself. That is called standard form for a trinomial. So we're going to see most of our problems for trinomials have something x squared plus something x plus a constant. Anytime the highest power term is x squared, it is called quadratic. You might have heard that term before. Quadratic might be a new term for you. So anytime you see an x squared term, it's called quadratic, not linear. So in this class, we really just study linear equations. In 0310 in college algebra, you're going to learn a whole bunch more about what are called quadratic equations, and that's again when you have an x squared term. So that's just kind of a side note. If you see the word quadratic, if I say the word quadratic, it just means that you have an x squared term. Alright, so what I'd like you to do is kind of fold your page down the middle with the rest of the space. We're going to make a T-chart with steps on one side and an example on the other, just like we did for grouping. So make a T-chart, steps on one side, example on the other. That way when you go back to your notes, you can really see what the steps were. Alright, step 0 is to look for and factor out any GCFs. Look for and factor out any GCFs. I call this step 0 because you're going to do this before you do any sort of factoring. You're going to look for those GCFs and take them out. So in my example, I'm going to have x squared plus 7x plus 10. Now remember, when this is all said and done, I am looking for back-to-back parentheses. Remember, you don't have to write this down, but I'm looking for two binomials that multiply together to make this trinomial. It's like I'm taking this trinomial apart into its two pieces, the puzzle pieces that fit together. So the directions are going to say to factor completely. The directions for the rest of this chapter are just going to say factor completely. You're going to be given a trinomial. You look for and factor out any GCFs. Let me show you what the coefficients are that we're looking at. There's a number in front of x squared, which happens to be a 1. We just don't see it. Positive 7 and positive 10. Our job is to look at those coefficients and see if there's a GCF. Then look at the variables x squared, x, and a constant to see if there are any GCFs. I do not see any GCFs. And I always like to make a note that there are no GCFs. That tells your brain that you checked for them, and physically writing it down helps you remember to look for GCFs. So step 0, look for and take out any GCFs. There are none for this problem. Step 1, you're going to multiply C times A and create a 2-column, what I call T chart. Multiply C times A and create a 2-column T chart. So on your trinomial, it's always in this order. Whatever coefficients in front of x, we call that A. So in this example, A would be 1. Whatever numbers in front of the x term, we call it B. And whatever the number is that's by itself, the constant, we call C. So whatever's in front of x squared is A, whatever's in front of x is B, whatever's by itself is C. That's where the ABC comes in. So we're going to set up a little chart, CA. You're going to do C times A. And next to it in the other column, you're going to put B. And that's referring to the coefficients in front of your terms. The book calls this the AC method. Multiply A times C. I switch them. It doesn't really matter. I switch them to C times A because it spells the word cab. And a student pointed that out, and it helps them remember how to set it up. So it spells the word cab. So A is 1, C is 10. So this would be 10 times 1. 10 times 1 is 10. And then in the other column, we're going to put the letter B. Whatever B's coefficient is, you're going to write that number down. So C times A in one column, B in the other column. So that's step number 1. Step number 2 is to think of two values that multiply to C times A and add to B. This is a really challenging step for some students. Some students, this comes very simple. This is like when you're putting together a puzzle. We know puzzle pieces have to match color and shape. So if you've put a puzzle together in your life, when you're trying to put two pieces together, their colors have to match and their shapes have to match. If the colors match and the shapes don't, they won't fit together. If the shapes match and the colors don't, the picture won't work. So you're always having to have two conditions, color and shape. It is the same idea here. We need both conditions to be true. It needs to multiply to CA, and at the same time it needs to add to B. So your job is to think, and I know that seems kind of silly, but you actually have to really think about this. Go through a process of elimination and think about all the things that multiply to 10. 1 times 10, 2 times 5, even get creative, -1 times -10 also multiplies to positive 10. -2 times -5 also multiplies to positive 10. You have to think of every single thing that multiplies to 10. Then, with those pairs, you're going to add them together. 1 plus 10 is 11. 2 plus 5 is 7. -1 plus -10 is -11. And -2 plus -5 is -7. So you think of the factor pairs that multiply to 10, then you add those numbers together for column B, for the second column. Your job is to find the pair that multiplies to 10 and adds to 7. There's only one magic pair that makes both of those conditions true, and that is 2 and 5. So that is the pair I want. 2 times 5 is 10, and 2 plus 5 is 7. So that is your magic pair, your two values. That's the hardest part of the whole process, finding that magic pair. Once you have that pair, step 3 is to rewrite the trinomial, oops, can't spell, trinomial splitting the middle term using the two values. This is easier than it sounds. You're going to rewrite the trinomial splitting the middle term using those two values. So we're going to leave the first term alone, x squared. We're going to actually split the middle term into two pieces using the two numbers we got here. So instead of writing 7x, we're going to put plus 2x plus 5x. That is still 7x. We haven't changed the problem. We've just split it into two pieces based on the two numbers we got here. Then we will leave the plus 10. So step 2 is taking your trinomial and turning it into a 1, 2, 3, 4 term polynomial. Make sure every step makes sense here. I'm going nice and slow. From here, you have 4 terms. So step 4 is to factor by grouping, which is the skill we learned in class. Factor by grouping. So you have to be good at factoring by grouping because that is part of the process for factoring trinomials. So you're going to look at the first two terms and take out the GCF. Between x squared and x, the GCF is x, and that leaves x plus 2. You're going to do the same thing for the second two terms. Between 5x and 10, the GCF is positive 5. That also leaves x plus 2. Just like we talked about in 6.1, those leftovers should match. And your answer is x plus 5 times x plus 2. Remember, we're trying to get the two back-to-back parentheses that make this picture. Some students like to add a step 5 to this process. It's totally up to you if you want to add this step, and that is to FOIL to check your answer. Some students like to check, some students just trust and don't check. It's up to you. I would recommend checking. So we're going to FOIL to check our answer. X times x is x squared. X times 2 is 2x. 5 times x is 5x. 5 times 2 is 10. So this is x squared. These two come together to make plus 7x plus 10, which is the picture you started with. Your answer, again, are the two back-to-back binomials. Alright, I'm going to stop the video here and make a second video. These are the basic steps, and the second video is just a series of examples, and you can just walk yourself through the examples as needed. So this is the end of part 1.